Welcome. On this show, we do unscripted, unedited videos about Linux programming and stuff. If you're new to the channel, check out the description below. It'll have some links to some details. Today, in this video, I'm going to pick up where I left off with the previous. I am starting to experiment with a little prompt engineering to create a client and server program. And so we'll just kind of pick up where we left off. In the previous video was 42. We ended up creating just these hello world programs. They truly are empty, but the goal was simply to start the prompt and get it to create the two different programs, both the server and the client. And in this video, we'll try and get some real functionality out of it. It shouldn't be too hard. What I'm going to do is drop it into the terminal here. We'll do CD crud LPS. Down into, I don't need this videos. I'm seeming not to need this videos folder, so I'm going to get rid of it. And then drop down into this prompts folder. It seems to be what I'm using this for. We'll just start by making a copy of 42 to 43. Drop into that. Drop into that. And then we'll start with this prompt. Okay. In the previous video, I had decided that I am going to try and we're going to write this. It's intended to be a single-threaded network loop that accepts thousands of connections, processes a binary message protocol between it and the client, and is using poll instead of epoll. We're going to switch to epoll in the future. So I think the very first thing is let's try to get, put a little separation there so I can see the two apart. Let's try to get the basic network loop. So what I'm going to tell it is the server program should accept network. I may end up refining this. This is, I'm just starting to think it through. The server program should accept network connections in a main should accept server connections in a single thread. The server program should be a single threaded network model using poll to read message data. The server program should, let's probably change the order of these. Let's do this. The server program should accept connection. The server program should accept network connections on localhost port 4242. It doesn't matter. Okay, so we start with the server program should be a single-threaded network model using poll to read message data. The server program should accept connections on localhost port 4242. Should accept many long-running connections on localhost port 4242. The server program should read binary formatted messages The server program should expect a binary formatted message that consists of a fixed length header and a variable length body. The server program should expect the message header to contain a uint32. That is a damn big message. So let's just do a uint16. The server program should expect the message header, actually, to contain a uint32 that defines the length of the body. It isn't going to be only that. So we're going to have different types of messages. So the server, the message header should consist of two fields. The message type and the message length. The message type should be an enum. The message type should be an enum that defines please enum. Provide three example message types. Echo, time, echo, reverse, and time. The echo message should return should generate a response to the client that contains the same body and it contains the same data that contains the same the echo message should generate a response to the client that has a body matching the request, that has a body that is identical to the request. The reverse message should let's do this. The message header should consist of two fields, the message time and the message length. The message body should be a null terminated string. The message body we'll start with this. I'm not really, I need to ask it to do some error checking here probably, but I'm going to say the message body should be a null terminated string. Message bodies provide three example message types, echo, reverse, and time. The echo message should generate a response to the client that is identical to the request. The reverse message should generate a response to the client with the body reversed. The time message should generate a response to the client that contains an ISO 8601 formatted timestamp. Yeah, we'll do that. Okay. So we haven't updated the client at all. I haven't put any kind of error handling in here. But we should, well, I've written enough here that I definitely need to test that we are even building a compiling program. But it should also give us a little bit of insight into where it's going to go here, because we really didn't define how the network loop and the message loop interact with one another. Where did I start to describe the messages? So right here, the message header should consist of two fields, the message type and the message length. Message body. Provide 3 example message types, echo, reverse, and time. The message types, I'm going to elaborate on that. The message types should be defined as an enum in a common messages header file. Then I'm going to ask it to, in a common messages header file, shared by the client, the server, and the server client and server. Provide 3 example message types, echo, reverse, and time. The echo message should generate a response to the client that is identical to the request. The reverse message should generate a response to the client with the body, with the text message in the body reversed. The time message should generate a response to the client that contains an A's for a string. We'll do that. Okay. Now, I haven't updated client at all. It might go and do it for us. You never know. What it actually would do here is going to be slightly determined by the temperature and other settings as to whether it wants to go and get creative on us. Everything is currently just set at the default values. So we'll run that prompt, see what we get, and then we'll work on the client and we'll try to compile it. I mean, I'll try to compile this, but the goal here in this video is just to get the two talking to each other without making it significantly more elaborate than I've just described. So we're getting up here a little bit more higher. I think we were 2,500 tokens before. We're at 3,781 right now. All right, seeing the enum go by with the, so we got our messages header. It's got the enums in it for that. It has a struct for the header. It uses poll. I don't remember if I asked it to use poll. Did I? I think I did. Maybe. I know that's the plan. I just don't remember if I did it. The program should. Yep, using poll. Okay. So what do we got? Initial file descriptor capacity, I imagine. ISO string length. Oh, I suppose I never thought about it, but it's actually a fixed length. because it expands everything to 4 characters, 2. Okay, so it's always the same length. That's nice. It reads exactly count bytes. Okay, I'll come back and read this in a second. It certainly, at a glance, looks like it's doing what we wanted. We have our switch statement here for handling the messages as they get built up. Okay, so let's save server. Well, we're going to need the header file here first, so let's find that. So this is messages.h, and we need it into the 43 folder. So let's come over here and get rid of the C files first. Okay. So this is messages. I think that's what it is. It might be message. I'll fix it here in a second. So yeah, message.h. I'll fix that. And then here we have server.h or server.c. Find the bottom. I wish it had just a download a tar and then I could expand it. Server.c. And then here we're going to have client. Oh, it did write a client for us. I kind of thought it. No, what did I do here? Yep, client C. So I didn't ask it for anything specific. So this is just it getting creative and assuming the client goes with server. I kind of thought it might do that because we got the temperature up high enough. Client.c. And then we need the makefile. Makefile might not even change, but we'll makefile. Okay, now clear. Let's move messages to message.h. Let's make that. They both make. Let's run server. And I'm going to need a... okay, so it looks like it... so it sent a message. Here it clearly did. So here it's just doing a regular. Here it's doing a reverse. And here it's getting the timestamp. Okay, so let's take a look at the code a little bit. Let's get rid of that. Let's stop that. Okay. It's a good start. Let's see what we got. So let's take a look at server. I don't think that's actually necessary. I don't know. I mean, yeah. I'm sorry. My brain just exploded there for a moment. I was trying to decide if... It seems to me that standard C something or other gets defined if you do the dash standard C18 or C17 or whatever, and I'm not sure that that's required. The POSIX C source, the POSIX C source defined is necessary. I'm not going to argue at the moment. That's splitting hairs. Okay, so let's just start from main. Tells us the server is starting. It getting the listen file descriptor. Set sock options, listen file descriptor. I have to go back and remember the exact steps here, but clearly so we're binding to our listening socket. what I'm looking for is the top of a loop eventually here, right? So we do all the setup to for the socket and start listening. Then we do this setup for poll. I don't know poll, so I'll have to go back and learn it. It clearly worked. So it is allocating memory for all of the file descriptors, max, so FDS, FDS, initial FDS capacity. So it's only accepting 21, it looks like to me like it's only initially accepting 21 connections. The first file descriptor is always the listening socket. And I don't quite, I mean, I don't understand anything about polls, so I'll have to just go back and learn that. But I wanted to see the code to be able to raise questions to learn from. Here we go into the infinite loop. So everything up here, in fact, it just says it there. Everything to there is just, it first set up the socket. It's then set up everything for poll, for poll. It goes into an infinite loop. Here it's saying, hey, wait until, I'm assuming, it's saying, hey, wait until any of those file descriptors have anything to talk about. And it specifically is using file descriptor 0 to look for new connections. If it gets a new connection, add the new client to the poll FD array. So that makes sense. We're going to take that connection, add it to the array of things that we're going to poll on. With some error handling. Then we, if essentially we're saying, hey, if this wasn't for FDS 0, and specifically the poll and event, then it must be something else. We look to see, check if the existing clients for data or disconnection. So data or disconnection. Here we're looking for, we're going to loop through all of the file descriptors. So we handle the connects first, then we loop through all of them. And we say, hey, are you polling, poll H up, poll up, and poll error? We'll have to look those up and understand them better. Basically, those are the things we're handling. If the client closed or error, remove it from the set. Makes sense. For size TI equals, so then we close. Okay, so where was read? Is that handling here? So, a couple of things that I'm not quite following is how do we know we get to the where are we like seeing the message size? I'm really gonna have to read through this code later on. Where are we seeing the message size? So we're seeing the header. We know we can read that, but like obviously we're already jumping off to handle client here. Oh, I'll bet you there's still networking code in handle client. That's what's going on with this. So it's just saying, hey, I'm actually reading shit, so let's go to handle client. Oh, I'm not in the actual thing. I don't have tags set up here. So let's go to handle client. Okay. Handles a single client connection. Read the fixed size header. Okay. So when it gets a connection, all it does is hand off to handle client, and then that will start to process it. And so we call read all here, which I want to find on the client file descriptor and the header and blah, blah, blah. And we read. So I get the feeling that this is still written in a way where it expects the client to hang up after. I mean, clearly it has to support the client disconnecting eventually, but convert from network to host byte order, read the variable length body, receive the message, process message, prepare response. Okay, I'll have to come in and do a little better job with the with the prompts here in the future, and to really piece out. Well, let's just. Okay, so then it switches on the header type. It's going to do something according to the header type. It's interesting that I'm picking this up from the AI. I'm downloading it, and I get the extra junk spaces in there. And then after it processes, it sends the response. It frees the response body. Okay, so let's jump back up to handle. So here it did handle. No, I think it waits for them to close. So it keeps them open. And what we'll do, I think I think that's actually a pretty good start, right? Let's work on client to make sure that, I'll have it like process messages for, or to send a message every second for, a random message every second for 15 seconds, and then we'll know that maybe even longer, 30 seconds, and then we'll be able to run multiple of them at the same time. I think that's the next step for that. But looks pretty good. We're going to continue to prompt this a little bit forward. I'm just going to go a little bit forward, and I'm going to get the client to be doing exactly what I want it to do. The server is essentially doing what I want it to do. It's not structuring the code the way I want it. So I think we'll first get the client to do what I want it to do. Then I want to look at the differences. I want to see just how much complexity ePOL adds. Here's a question that I don't need Gemini for, which is what's the max? The number of connections in the connection pool. So this is not really, what's the max simultaneous recommended connection, socket connections when using poll versus ePOL? Yeah, here's what hopefully this is what I want, right? Which is a look at select ePOL poll. Don't smack me in the face yet, blah, 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 blah. I just want some numbers. See what they get to at the end here. Okay, so he's doing them one at a time. I want to look at poll versus, so this is poll. Runs all the way up to 10,000. On 100 threads, so he's doing 1,000 per thread. 3 seconds. Well, there's a huge difference there in performance. I mean, this is Go, but it's still 100% relying on the underlying network calls, right? And that's going to be the system. But 3.5 seconds versus 1/10 of a second is an enormous difference. So yeah. So clearly that's of interest. How much more complicated does and that's actually right in the exact ballpark that I'm interested in. I expect we're going to be running with around, I hope that someday I can run with around 1,000 simultaneous connections, simultaneous users. And at the same time, I want to design for 10 to 20,000 simultaneous connections. So it looks, certainly looks doable, and it certainly looks like ePoll has to be the answer. And so our progression here is really just more an educational thing. We know we're not going to use poll, but I want to kind of compare the two, see how complex one is, ePoll is. Okay, I think what I'm going to do here, since we actually at the moment have a working, my brain, sometimes I just don't understand. At the moment, we have a working prompt, and we've run about 30 minutes or so for this video already, I'm sure. I'm going to stop here, and I will pick this up in the next video, where we will try to improve the client a little bit. And then after getting the client to do what we want and test it, and so to make sure they have multiple simultaneous, we'll start to tune, we'll first switch to ePoll, compare it. I might be talking a couple of videos ahead here, but we'll first switch to ePoll, we'll compare it. I might do a little bit of a dive into understanding ePoll and all the different steps you go through to set it up. Then I will probably start to tune the code generation in the prompt, so we're getting a little bit more of the layout of the code that we want. And we'll probably end up exploring things like using a message queue to process them and things like that. The end goal isn't a single thread processing messages with ePoll. It's to have, my end goal would be to have n threads all reading in a loop if possible. Or maybe it is still the right way is to do it with a single thread and then just dispatch to push the messages into a queue and let multiple worker threads, some fixed number of worker threads, process off of that queue. Right now, that seems like the most likely way, but we'll find out when we get there. I'm gonna let Gemini write the code. Maybe as a fun experiment. After we do it with Gemini, maybe we go do it with ChatGTP or Claude or something and see what we get. Anyway, I'm gonna wrap this video up here. I will see you in the next video.